So this is a question from GATE 2015 Chemical Engineering GATE question number 56. So consider two isothermal flow configurations shown schematically as case 1 and case 2 below. In case 1, a CSTR of volume V1 is followed by a PFR of volume V2, while in case 2, a PFR of volume V2 is followed by a CSTR of volume V1. In each case, a volumetric flow rate of liquid reactant is flowing through the two units in series. An irreversible reaction A gives product of order N takes place in both the cases with the reaction concentration Ca0 being fed into the first unit. So these are the two cases given. We have to choose the correct option for this. So we have to choose the correct options from these four options. So option A will be Ca final of case 1 by Ca final of case 2 greater than 1 for n equal to 1. Option B, Ca final case 1 by Ca final case 2 is equal to 1 for n is equal to 1. Option C, Ca final 1 by Ca final 2 less than 1 for n equal to 1. And option D, Ca final 1 by Ca final 2 is equal to 1 for n greater than 0. So this is a question from combination of reactors from chemical reaction engineering, and the reference NPTEL series can be found in module 1, lecture 26, reaction design for mixed flow reactors and combination of reactors, chemical reaction engineering 1, homogeneous reactors by Professor K. Krishnaiah, Department of Chemical Engineering, IIT Madras. So to do this problem, let's see how we can proceed with this. So let us take a reaction like this. A gives B, and the order of this reaction, let that be 1, and the reaction rate will be given by minus Ra is equal to Kca. So let us take case 1. So in case 1, it is CSTR followed by PFR. So let us take a CSTR, and this is followed by PFR. Let us take the entry point as Ca0 and Q0 or Q, whatever. Then Ca1, and the final outlet concentration is CAF. Alright. And let tau1 be the spacetime of CSTR and tau2 be the spacetime of PFR. So obviously V1 will be the volume of CSTR and V2 will be the volume of PFR. So now tau1 can be written as V1 by Q, which will be equal to Ca0 minus Ca1 by Kca1. That is basically, this is the design equation of the CSTR. Now if we write the design equation of PFR, it will be tau2 will be equal to integral of Ca1 to Ca2 minus dCA by minus Ra, and minus Ra will be Kca. Right. So this will be design equation of PFR. So now let us try to simplify these two. So here what we need to do is, we'll take a balance, component balance. No, we don't need to take a component balance here. We can just rewrite the So let us take this as equation 1 and this as equation 2. Okay. So now from equation 1 we have V1 by Q is equal to CA0 minus CA1 by K CA1. Right. So we can just rewrite this. So V1 K CA1 will be Q into CA0 minus Q into CA1. Okay. And from this we can write CA1 will be equal to Q CA0 by V1K plus Q. So this will be the equation of CA1, which is the intermediate concentration here. So we can even simplify this a bit more. So let's say we divide this whole thing numerator and denominator by Q. So this can be written as CA0 by V1 by Q into K plus 1. And what is this V1 by Q? That is basically tau 1, right? So CA1 will become CA0 by tau K plus 1. Right. Now we go for equation 2 with respect to PFR. So for PFR we wrote that tau 2 is equal to integral of CA1 to CAF minus DCA by KCA. If we integrate this, basically it will be 1 by K ln CA from limit CA1 to CAF minus 1 by K. And so tau 2 will be basically 1 by K ln CA1 by CAF. Now if we take this K to this left hand side, it will be tau 2 K will be ln CA1 by CAF. And from this CAF will be, we have to find this CAF. We can find that by taking the exponential from both sides. So taking exponential of tau 2K will be basically CA1 by CAF. So that means CAF will be CA1 e raised to minus tau 2K. So this will be CAF, and we also have the CA1. So CA1 is the concentration of A after PFR, and this will be the final concentration of A. Okay, so this is the final concentration of A after the PFR. So we have the equation for CA1 here. We just substitute that CA1 equation in this CAF. So CAF will be equal to CA0 by tau K plus 1 e raised to minus tau 2K, tau 1K. Yeah. So this is the final concentration of A after passing through the CSTR and then the PFR. Right. Now let us look at the next case, case 2. Now in case 2, first PFR will come, and then that will be followed by CSTR. Now previously we took tau 1 for CSTR and tau 2 for PFR. So we will follow the same nomenclature here to avoid confusion. So tau 2 will be the spacetime of PFR and tau 1 will be the spacetime of CSTR, and consequently V2 and V1 will be the volumes of PFR and CSTR respectively. Now this will be the entry at PFR will be Ca0, Ca1 will be the final concentration after the exit at PFR, and CAF will be the final concentration after this whole combination of PFR and CSTR. Now what we'll do is we have to find this CAF here, and let us see how we can find that. So writing the design equation for the PFR first, because PFR comes first. So we write the design equation of PFR, that will be basically tau 2 is equal to integral of Ca0 to Ca1 minus dCA by minus Ra, and that will be integral Ca0 to Ca1 minus dCA by Kca. So this is basically minus 1 by K ln Ca from Ca0 to Ca1, and we can write this as 1 by K ln Ca0 by Ca1. So tau 2 is equal to 1 by K ln Ca0 by Ca1. We can rearrange this a bit. This will be tau 2K will be ln Ca0 by Ca1. If we take the exponentials, it will be e raised to tau 2K, that is equal to Ca0 by Ca1, and that means Ca1 will be Ca0 into e raised to minus tau 2K. Right. Now if we take the case of design equation, so this is the design equation for PFR. Now we do the same for CSTR. For CSTR, tau 1 will be Ca1 minus CAF by KCAF. Now rearrange this. Tau 1 K CAF is equal to CA1 minus CAF, and tau 1 is basically V1 by Q. So V1 by Q K CAF is equal to CA1 minus CAF. Now what we have to do is rearrange this. If we rearrange that equation to find CAF, so CAF will be Ca1 by tau K plus 1. Okay, now from here we have Ca1. So we substitute that Ca1, that will be, so CAF is equal to Ca0 into e raised to minus tau 2K by tau 1K plus 1. So this is the final concentration of A after the combination in case 2. Okay, so now let us just write the final concentrations of case 1 and case 2 together. So for case 1, Yeah, so this is case 1. So for case 1, we can see, CAF. So we'll write it as CAF case 1 is equal to CA0 by tau 1 k plus 1 e raised to minus tau 2 k. And for case 2 also, CAF is equal to CA0 by tau 1 k plus 1 e raised to minus tau 2 k. So from this CA1 and CAF2, we can see that both these are same. So that means for order n is equal to 1, CAF case 1 by CAF case 2 is equal to 1. Okay, so out of these 4 options, the right option here is option B.